Okay, we're going to go ahead and talk about lesson 12-2, which is inequalities. Okay? All right, let me erase this. I made a first video for this and realized I did something wrong, so we're starting over. All right, so inequalities. Okay, an inequality uses like the greater than, these signs. Okay? And you've worked with, I know, these signs. I'm comparing numbers. 5 is greater than 3, right? Okay, you've worked with these before just by comparing numbers. Okay, so that's what an inequality is. Okay, an inequality, now what we see this because instead of having numbers on both sides, we're going to have a variable. X is greater than 3. Okay, now first of all, you would read this as x or a number greater than 3. Okay. Now, is there one solution to this? No, there's infinite number of solutions. It's basically any number that's larger than 3. Could be 4, could be 8, could be 20, could be 1,000, could be 5 billion. Okay, so in an inequality, there's not going to be just one set answer. It's going to be a range of numbers. Okay, so they're going to have you graph inequalities. And when they say graph, what they mean is they want you to first draw a number line. Okay, and as I set up this number line, how I don't necessarily, I know when you set up a number line, you're usually like 0, Okay, how I set this up is I look at the number 3, okay? That's kind of around where I'm going to be. So I'm going to put 3 in the middle, okay? And then I'm just going to do a couple ticks to the right, to the left, and then kind of fill in the numbers that would go. So this would be 1, this would be 2, this would be 4, this would be 5, okay? I don't need 5 billion numbers. All I'm going to do is show a range, okay? So x is any number greater than 3. So I'm going to go to 3. Now, I'm going to put a dot here, okay? But I'm not going to shade it in because 3 itself is not a solution, right? 3 is not greater than 3. So 3 itself cannot be a solution. That's why I'm not going to fill the dot in. That just says 3 itself is not a solution, but that's kind of my starting point because I could go just a little bit. 3.000001 is a solution, right? But 3 itself is not. Okay, so which direction of the number line would I go to for all the numbers that are solution? Okay, are 1 and 2 solutions to this? No, 4 and 5. So I would go to this direction of 3 to find all the numbers, right? It keeps going on and on and on forever for all the numbers that are solutions. So as I graph this, I have my starting point at 3, but I leave it open because 3 itself is not a solution. And then I'm going to kind of bold this line. I'm going to make it really thick. Okay, and then show that it's an arrow. Okay? Basically, that's showing that the solutions for this inequality, x is greater than 3, is pretty much any number go in this direction on the number line. Okay? So that's how you would do that. Now let's try another 1 or 2. Okay? Let's do x is less than negative 2. Okay? So we'd read that as x or a number, any number less than negative 2. So I'm going to go ahead and graph that. Okay, so again, negative 2 is kind of my starting point. So I'm going to start with negative 2, a couple ticks on each side. So numbers less than negative 2, remember this is like smaller numbers. So 3, negative 4, negative 1. These are our bigger numbers, 0. Okay, so I set up my number line. So x is less than negative 2, so I'm going to put my circle at negative 2. I'm not going to fill it in because negative 2 is not a solution, okay? It's just kind of my starting point for basically every number. So now which direction am I going to go? What are the numbers that are less than negative 2? Is negative 3 less than negative 2? Is it smaller? Yeah, it is. Okay, so I know that pretty much all my solutions are going to be this direction. So I'm going to go ahead and then like shade it in. And then just draw my arrow, basically saying that all the solutions to this, there's an infinite number of solutions, but all the solutions are this direction on the number line from negative 2. Okay? All right, one more example. This one's a little bit different, okay? It's going to be written different. Okay, x is greater than or equal to 4. Okay? Now, this one's a little bit different. I don't know if you've ever seen this before. And I know you've seen the greater than or less than sign, right? But now there's a line under this, okay? What that means is, I would read this as x is greater than or equal to. That's what that line means. It could be equal to 4, okay? So with that, Could 4 be a solution? Yes, 4 is greater than or equal to, or is equal to 4, okay? That's the difference between this. This just means that this number could also be a solution, okay? So that's gonna look a little bit different when I graph it, okay? So again, do my number line. Start with 4 in the middle, couple ticks on each side. So 2, 3, 5. All right, so I'm gonna start at 4 like I had been, draw my dot, but this time, could 4 be a solution to this? Yes, it could be. So in this case, I'm gonna actually fill the dot in. And that means 4 itself could be a number, could be one of the answers, okay? So x is greater than or equal to 4, okay, so which direction do I need to go on the number line to find the solutions? 5 is greater than or equal to 4, 6 is greater than or equal to 4, so I'm gonna go this way. And then just draw that out. And that's how I would graph that. All right, let's see. I think that's all you really need to do. They're going to give you like word problems that they want you to turn into an inequality, okay? So like an example from the book is no more than 45 students work in the car wash fundraiser, okay? So 45 is the key. Okay, X is the number of actual students that could do this, okay? So when it says no more than 45, okay? So can this number be larger than 45? No. Basically, X is going to have to be a number that is less than 45. Now, but we have to ask ourselves, no more than 45. Okay, so could 45 itself be a solution? Yeah, because 45 is no more than 45. So then I'm going to do, so X, being the number of students working at this fundraiser, has to be less than or equal to 45, okay? Let's read one more example and kind of show how, and then they might have you graph that. And again, you should know how to graph that by now. Okay, there are more than 15 ladybugs on the windowsill. Okay, so 15 is my key. X is the number of ladybugs, okay? There are more than 15, okay? So is X a number larger than 15? So it's going to go X is greater than 15. Now we got to ask ourselves, is 15 a solution? There are more than 15. Okay, could 15 be a solution? No. Okay, and X is the number that is larger than 15. So we just leave it as X, the number of ladybugs, is more than 15. Okay, so that's how you would basically take word problems and then translate it into an inequality. All right, so good luck with this section.